15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Hope you're staying safe and well. My name's Andrew Dunkley, and you are listening to episode 195 of the Space Nuts podcast. And with me, as always, is astronomer in charge, an astronomer-at-large. I've gone back to the egg. Astronomer-at-large, Professor Fred Watson. Hello, Fred.
Hello, Andrew. Yes, still at large. Well, actually, not quite at large. I'm shut up at home, but that's all right. I'm at large within my house.
Yes, yeah. We'll talk about that later because you actually got a question about your situation. So we'll tackle that in our questions segment. We're also going to look at the possibility of a naked eye comet in our skies in a month or two. This is one that was discovered fairly recently. One wonders if it will rival that great comet of 2007, Comet McNaught, which I saw. It was actually at its brightest around Australia Day, and I was at an Australia Day event, and that evening we all went outside and just looked in awe at this thing. It was amazing. So I'm hoping it'll be something like that. And I love this story. I so love this story. You know, in this age of such modern technology and complexity, the InSight lander on Mars. Remember we talked about that, and the drill got stuck and they couldn't figure out how to fix it. Well, it's fixed, and the way they fixed it, awesome. We'll talk about that soon. And questions from Josh about the oscillating universe theory, and Paddy wants to know how to take photos through his telescope, which, it's a great question. I mean, it's good to be able to look at these amazing things in the universe, but even better if you can record them and maybe frame the picture and put it on your wall or something. Actually, Mr. McNaught was very good at that. We'll talk about all those things today, but first, Fred, a naked eye comet. I remember in 1986, I think it was, that I was very excited to be able to go outside and have a look at the Halley's Comet. And what a huge disappointment that turned out to be. It was just a fuzzy ball that you had to squint to see. I think people had waited all those years, 7+ decades, to be able to see it, and they went, oh, well, okay. Maybe next time.
See, if you'd read your astronomy books from 1910, when it had its last apparition, you would have known that it was going to be a fizzer in 1986.
Yeah, but you know how things go. People, the stories I heard as a kid was, it just flashed across the sky in seconds, a big fiery ball, which was absolute garbage.
Well, and in fact, the thing about Comet Halley, it caused a sensation in 1910. And if I remember rightly, that was the year that the comet actually passed, or the Earth passed through the tail of the comet. And because people knew by then that there are some quite complex molecules in the tails of comets, including cyanide compounds, there was terror that the Earth was going to pass through this comet's tail, which was laced with cyanide, and we'd all die.
And it was officially called COVID-1.
Yes, something like that. Of course, none of that happened. It was perfectly harmless. But even back then, everybody knew, certainly in the astronomical world, knew that the next apparition in 1986 would be not really worth writing home about, because when the comet was at its brightest, it was actually on the opposite side of the sun from the Earth. Yeah. And so, it's just a very bad geometry for seeing bright comets. Which leads us to the current tale of what is being called Comet ATLAS, and has some sort of promise of becoming bright. Although I have to say, you mentioned earlier Comet McNaught, which was discovered by Rob McNaught at Siding Spring Observatory in late 2006, and early in 2007 was utterly spectacular.
Wasn't it?
Yeah, it was phenomenal. Sadly, only from the southern hemisphere.
Yeah, and you know, we didn't have digital technology like we do now, so nobody had mobile phones and digital cameras in their pockets. So not
right.
many private photos. Today, though, it could be a different prospect.
That's right. And certainly, I mean, a lot of the best photos were actually taken by Rob McNaught himself. But it was night after night, it hanging in the western sky with this structure in its tail that was really quite extraordinary. So coming back to the present time, we need to preface this discussion by the caveat that applies to all comets. I can't remember who said this, but it was a long time ago. And it's very appropriate because Mandu's wandering around somewhere at the moment. The quote is, comets are just like cats. They have tails and they do anything they like. So you never really know with a comet. Let's look at the physics. What you've got is basically a like an iceberg. Oh, it's come back to
exactly. Mandu.
You mentioned my name. Yes, I did. Yeah. The comet is like an iceberg, basically a mountain-sized or maybe a mountain range-sized lump of fairly loosely packed ice with lots of dust in it. Sometimes, I think Halley it's certainly less than 10 kilometers across. We talked long and in great detail a few years ago about Comet 67P, Churyumov-Gerasimenko, which was visited by the Rosetta spacecraft. I think that was about, if I remember rightly, 1.5 kilometers. It's quite small. I can't remember. Anyway, they're not big objects, but what makes them visible and what makes them so bright is that when they get near the sun, and remember they're in very elongated orbits, they come in from way out in the depths of the solar system, pass by the sun, and when they do that, the sun's radiation essentially vaporizes the ices in the comet, and you get this plasma tail. And in doing that, because the ices are being vaporized, it loosens the dust, and so you get often a separate dust tail, which is actually a different color from the plasma tail. A lot of really interesting images now, with, as you said, with modern digital technology, we can see all this. So as it comes in from its sojourn way out in the far depths of the solar system, comets, as they get nearer the sun, they start producing what's called a coma. The coma is the sort of glow of gas around the comet itself, around the comet nucleus. And that is what we're seeing at the moment with Comet ATLAS. We can see the coma. Its name is actually an acronym for the robotic survey that discovered it. The acronym ATLAS stands for Asteroid Terrestrial Impact Last Alert System. So it's a robotic system for looking for near-Earth objects, particularly asteroids, but of course anything like an asteroid. Works. Yeah, it does. It's not found an asteroid this time, but it's a comet. But comets, like asteroids, move relatively quickly through our skies, especially if they're near. And that's what is the threat, basically the trigger for things being recorded. So it was back in December when ATLAS was first observed. Actually, yes, it was the 28th of December, so right at the end of 2019. And I should give you the technical name. Comet ATLAS is actually C2019Y4. That's its formal designation. But usually with comets, they take the name of the discoverer, hence Comet McNaught, discovered by Rob McNaught. And since this was discovered by a robot, it gets the robot's name, which is ATLAS. So it was faint back in December, but what has alerted people, and the reason really why we're talking about it, is it's actually brightened quite rapidly, and that's encouraged people to wonder whether we will get a spectacular display. And actually, the astronomy world is a bit hungry for that sort of thing because there's not been much. Certainly nothing like McNaught. Comet Lovejoy back in 2011 was very bright. And 7 years ago, there was a comet called Pan-STARRS, named after another asteroid detection system, which was visible after sunset in the western sky. But these comets. Certainly, McNaught was very spectacular. The other two I've just mentioned, Lovejoy and Pan-STARRS, weren't so much so, but they created a lot of interest because they were naked eye visible. That's the point. You can see it with the unaided eye.
There's no way of predicting how bright this one might get.
Exactly.
But the hope is that it will be.
Exactly. At the moment, it's little more than a hope. I think you and I will probably keep an eye on this for the podcast. It gets closest to the sun, if I remember rightly, on the 31st of May. So it's still got a couple of months to go to brighten up. It's still fairly well out in the solar system. It's when comets pass their closest to the sun that they typically get brightest, because that's when they go past the sun, all this stuff comes off the comet, the plasma and the dust, and that then forms a tail which stretches actually not behind the comet. The tail stretches away from the comet in the direction opposite to the sun. It's a bit peculiar. It's because the solar radiation is the pressure that's pushing the tail outwards. It's not like a tail streaming behind something, as we'd expect, with a rocket or something like that. It's actually the tail direction is dictated by the direction of the sun. So what it means is that as they leave the solar system, often if they do have a tail, the tail's actually pointing the direction that they're going.
Yeah, that's right, away from the sun.
Away from the sun.
It prompts an interesting question. As it sort of does its turn around the sun, does the comet turn, or does the tail just spin around the comet?
So the comet itself is probably rotating anyway, independently of all this. And we sometimes see that with very detailed images of the center of comets, the center of the coma, the head of the comet. You can see almost like spiral structure in it as the comet's rotating, and it's got jets of material coming off it, and they turn into a Catherine wheel in the firework world. You get these spiral jets of material. So you're right, though, that the tail itself turns away from the sun, but that is what gives the tail its curvature, because the particles or the gas in the tail is heading off in a particular direction. The source of that material changes direction, and so what you get is a curve in the tail. And Comet McNaught had this extraordinary curvature. I remember it arching over the western horizon. It was really quite astonishing.
It was amazing. I still remember it so vividly. And it was just such a and like you'd go out at night and you'd just glance up and there it was. It was just it just dominated the skyline for a good while too.
Yeah, it did. That's right. Now you and I are now sounding like a couple of old men reminiscing about the great things of the past.
Yes.
Which is not not necessarily the purpose of this segment. But just to mention that at the comet's closest, it will be about 38 million kilometers. That's kind of 23 or so million miles from the sun. And we expect from that, a big increase in its luminosity. So it will brighten up. It seems almost certain that it's going to brighten up.
Oh, good. About half an AU.
No, an AU is 50 million. There's a very naughty cat here that's eating.
I can hear something going on.
Yeah, he's actually. Yeah, all right. I'm just prodding him to make him behave slightly better. He's eating the furniture, scratching it, like they do. He's got a soft spot for the lounge in this.
All right, so
sorry about that slight digression.
The possibility of this becoming decently bright is not confirmed, but hopeful.
It is. I mean, I suppose if we've got something that looks good in binoculars, then you've got something worth talking about. If it gets to naked eye brightness, so all you've got to do is look up in the right direction and see this fuzzy patch, then it's getting to be a big story. And if it develops a tail stretching halfway across the sky, like one of the comets, I can't remember, was that Kohoutek or Hyakutake, I think it was called. that had a tail that was really very dramatically long. If it does that, then if it pay dirt. Yeah. So the message at the moment is keep an eye on it, and we will try and bring the news to you as it arrives.
Indeed. And you mentioned it earlier on in 1910, the arrival of Halley's Comet, the world sort of panicked at the possibilities of disease and pestilence. And of course, when was this latest one found, Fred?
Yes, that's right. Isn't that extraordinary? I thought the same thing when we were having that conversation. That over thousands of years of human history, comets have always been regarded as portents of doom, as bad omens. And it's a bit strange because it's not obvious. I suppose it could be terrifying if you had a bright object in the sky that seemed to have a tail and heading towards you or something. That might actually impart panic. Just as an aside here, though, Andrew, two former colleagues of mine, Bill Napier and Victor Klub, in fact, I used to work for Victor at the Royal Observatory in Edinburgh, they were among the first to recognise that the Earth has been bombarded by asteroids and probably comets too. And they did a lot of research on Comet Encke, which is a comet that may have had fragments that have impacted the Earth. And they linked the fact that there were real horrors happening on Earth because of impacts from comet fragments to the tradition that comets are bringers of bad news. So there might be a physical history why we've always regarded comets as bad omens. But yes, it is remarkable that in the COVID-19 era, we have a comet that is going to grace our skies, I hope. We don't see it as a bad news story now.
No,
it keeps the eye business for a start.
It's just a sheer coincidence that the illness is COVID-19 and the comet is C2019. Just a coincidence.
Yes, that's right.
But we will keep an eye on that. There'll be more to tell real soon. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
3, 2, 1.
Space Nuts.
Once again, I'd like to recognise our patrons for signing up and putting a few dollars a month into the kitty to keep our podcast alive. You are wonderful, wonderful people. Really appreciate it. We're obviously aiming to sign up more patrons, but it's not mandatory. But we do particularly want to recognise those who are enjoying the podcast enough to want to volunteer some money in the bank. So thank you for that. If you're interested in doing that, patreon.com/spacenuts is the site, patreon.com/spacenuts. And it's just fantastic that you feel that strongly about the podcast, that you want to contribute financially. And we say it so many times, but we really do appreciate you very, very much. Don't we, Fred?
Absolutely. No, it's fantastic to have people who are prepared to do that.
Now, maybe NASA should have thought of signing up some patrons to fix the InSight lander, because it's had to figure out how to fix itself. Now, a little while back, you and I talked about the fact that it was trying to do a drilling operation, and the drill got stuck, and they didn't have a solution. Well, they came up with one. It's as classy as a plumber unblocking a pipe, in my opinion. This is awesome.
Absolutely. So the story is NASA's InSight rover on Mars. It landed on it did land on the planet, yes, in November 2018. So it's been there rather more than a year. And you remember that what InSight is all about is two big main instruments, a seismometer to listen to Marsquakes, and we've actually talked about the successful detection of Marsquakes on the planet, which is all, giving us insights, of course, which is why it's called that, into the interior structure of Mars. But the other big experiment was the thermometer. To lower a thermometer, I think it goes down about 4 meters, something like that. That's the idea, into the Martian soil. This is basically a drill that's got all the delicate equipment inside it. It's technically called a digging probe. And if you think of something about, I don't know, 35 centimeters long, 15 inches or thereabouts, it's that sort of length, but maybe an inch or so in diameter, 25 millimeters. It's probably got a spike on one end, and basically it's very cleverly designed so that it sort of vibrates its way down into the soil. The idea was that you would give it, you can give it an individual number of strokes to. I think there's a weight inside it. I think that's how it works. That kind of a bit like the old pneumatic drills that people used to use to dig up roadways, where there's basically a hammer inside it that hits the top of the drill bit, the sharp bit on the end, and it's the impact that actually gives the impetus to make a hole in whatever it is. So it's a very similar,
like a pile driver.
idea to that, yes, only perhaps a slightly gentler process, because you're talking about putting delicate instruments down. So the story is, which we've rehearsed many times, it actually got stuck not very far down into it, and in fact, I think we mentioned too that probably a couple of months ago, it actually bounced out again, and they were worried that they weren't going to be able to get it back in the hole because the probe sort of popped out and tipped over slightly. So the problem was always that you don't really know what has made it stop, why it's stuck. Is there a big slab of rock blocking the way down, or is it a problem of the mole itself, which is the technical term for this probe, not being able to grip the soil around the edge in order to give it some leverage, which is another, fairly viable possibility, because Martian soil is not like soil on the Earth. Anyway, the problem has been for long that it wasn't actually working at all, and people did talk slightly jokingly about giving it a clout with the hammer. It's a shovel really. Insight, like its predecessor, Phoenix, which is a very similar design. Insight has a robotic arm, and on the end of it there's this scoop. It really is, but it looks a bit like a tiny little backhoe shovel. So people talked about that, but they're very worried about doing that, because out of the top of the mole itself, the probe, comes all the wiring that connects it to the rover.
Yeah, you can see that quite clearly in the photograph that they've
that's right.
Taken.
There is a nice NASA picture showing exactly that. You can see the probe, you can see the wiring coming out of it, and in this particular photograph, you can also see the backhoe shovel, which apparently has been used to give it a good, a good slug,
a good old-fashioned thump.
A thump, yes, that's right. Which seems to have done the trick.
Yeah. I think it's hilarious. How do we fix this thing? Let's hit it with a spade. Done. Yeah, I can imagine them sitting in mission control, and you get the whole thing lined up, and of course it wouldn't happen in real time because of the time it takes for signals to get there. So you're watching this in past tense, really. So you get it positioned. It would have taken ages, I suppose, and then you push the button to make the thump or whatever it is they do, and you sit there and go, "Oh, I hit it too hard," and you've got to wait 20 minutes to see what happens.
Well, that's right. Yes, and see what it does. I think actually we're perhaps having a little bit of artistic license here, because I think what they actually did was use this backhoe shovel to push down on the top of it, just applying pressure, and I think
try and get it doing its thing, and
then get it doing its thing. So there's some words here from, I don't think they're a direct quote from JPL, Jet Propulsion Laboratory spokesperson, but the text here, which actually comes from Popular Science. While pressing down with the arm, the operators instructed the mole to dig for 25 strokes. That's enough to make it sink down a couple of inches under ideal conditions, 50 millimeters, of course, for those of us here in the metric world. Early images suggest that the mole has dug perhaps half an inch. It's about 13 millimeters. Although mission planners are anxiously waiting more data before they declare the instrument saved. So the signs are good, but the thing's not home and dry yet, if I can put it that way. There's some very nice quotes from one of the mission scientists who's involved with this work, whose name I'm trying to find. I'm sorry, I can't find this person's name, but there is they referred to this as Plan C, the idea of using the shovel, but there's NASA or JPL spokesperson talks about this as being their gardening skills, which are quite like, because the idea is to allow the mole to go all the way down. They've got to do things like covering up the hole that it's in. There's a few really interesting aspects of it. If they don't get the mole down significantly further, the conclusion will be that there is a rock or a stone down there blocking it. Yeah. But the signs at the moment are promising, and I think it's no more than that.
I like the other solution that someone suggested in terms of finding a way of dealing with this. Let's ask Mark Watney. Mark Watney was the character in the book The Martian who got stuck on Mars.
All right.
And
yes.
had to solve all these problems to survive. So yeah, I think there's the solution. Ask Mark Watney.
Yeah.
He'll figure it out.
Instead, we've asked Tilman Spon, who is the principal investigator on this, and that's the person who was making those quotes.
Yes, and that's a good quote.
Yeah,
I like it. All right, well, hopefully there'll be some positive news to share about the InSight lander and its robotic drill. You're listening to Space Nuts. Andrew Dunkley with Fred Watson.
Okay, we checked all 4 systems and team with a go.
Space Nuts.
Now, if you have not started following us on Facebook yet, now is the time, because nothing special will happen if you do. But it's a nice thing to do because you'll be able to keep up to date with not only episodes of Space Nuts, but other bits and bobs that we put on the Facebook page. That's the Space Nuts Facebook page. Or you could join as well the Space Nuts podcast group on Facebook. And that's where Space Nuts listeners join each other and converse and swap stories and ideas. And sometimes people will ask questions and everybody will chime in with their answers. It's a fun group. It's growing day by day. And it's a real thrill to have been partially responsible for putting you all together, because I can see much joy being had between the members of the Space Nuts podcast group. So they're on Facebook. Of course, you can also follow us on Twitter, I think. I don't know. I meant to say YouTube. I don't know why Twitter popped into my head. YouTube is where we've got a lot of followers now, well over 1,000, and the numbers are growing. So if you'd like to subscribe via YouTube, you can do that as well. Now, Fred, we've got some questions, but before we get to audience questions, somebody posed a question from the astronomical world to you in regard to COVID-19. Well, you're holed up at home because you're an old fart and you're not allowed outside.
Yes, well, that's probably a fairly accurate description, actually. Many people would agree with it.
Yes. So no visiting Fred at home. True. Very important. Do not go to Fred's place.
I think fart must be an acronym there. I'm trying to work out what it.
I'll make one up while we're talking.
Wait a minute. No, Fred at residence today. There you are.
Oh, that's the one. That's Fred at Reddit. Yeah, I don't think I can do better than that.
Okay. All right. So I am at home. I'm working from home. It's not. It's actually a personal choice, really, because we're being advised by our state government if we can stay at home, we should do, and I can. I can equally go into the office, but there's not really any need to do that at the moment. I can do pretty well everything I need from home. So I was asked by no less a person than I think the editor actually of the BBC Sky at Night magazine in the UK, which is both a printed and an online publication. A spin-off from the BBC Sky at Night programme, which, of course, has been going since 1957 and still is. I used to be on it in the days when Patrick Moore was covering it, if I went back to the UK. Anyway, so it's something very close to my heart because the Sky at Night is what turned a lot of us of my generation onto astronomy in the first place back in the 50s and 60s. So I'm always happy to help the Sky at Night magazine. So the question was, and I think this went to a lot of astronomers all around the world, excuse me, how is the COVID-19 pandemic affecting your work? How is it affecting the work of astronomers and space scientists? Well, we know, because we've seen in the media, that some space science is continuing unabated. We've had more launches of the OneWeb and Starlink constellations, but some has stopped, like work on the James Webb Space Telescope. That's currently being postponed. The world of astronomy is probably a little bit better off than many activities, because astronomers generally, certainly here in Australia, we're very used to communicating online, simply because we're so far away from most other places. Yeah. So it's very much a way of life to communicate by Skype or Zoom or other, online facilities. And a really good example of that is that remote observing on our telescopes, both in Australia and overseas, is standard practice, essentially. Because it saves travel. In fact, there is an interesting link here between another calamity that overtook certainly Siding Spring Observatory back in 2013, the Wombalong bushfire.
I remember it vividly because it also threatened the transmitter of the radio network I was working for at the time.
Mount St. Croix was in the Warrumbungle Range, which is the radio transmitter there on a mountain not very far from Siding Spring Mountain where the telescopes are, and that was a huge bushfire, 54,000 hectares. It swept over the observatory, thanks probably largely to the Rural Fire Service doing their water bombing from the air. None of the telescopes were destroyed. The lodge, the old Siding Spring Lodge, was burned down. So what that meant was that because of that bushfire, something that had been in the wings for a while was brought forward, and that was remote observing on the Anglo-Australian telescope. And very quickly, it became a standard operation because the network links were good enough. Astronomers actually suddenly realized that they could make their observations from their home city. If it was only Sydney at the time to start with, but now we've got nodes all over the country that allow astronomers to work from almost their office, sometimes from home as well. So, and that's for the domestic facilities. Likewise with the radio telescopes, it's very much the case with overseas facilities too. It's also for us in Australia very commonplace that we attend meetings over the internet, simply because they're often in Europe or North America or wherever. And many astronomers in this country, in Australia, belong to very large international collaborations, like the RAVE, the RAVE collaboration that I've been closely involved with, and another one called Galar. So it's very much a stock in trade, and I think it's true to say that many Australian astronomers now are like me, just working from home. The telescopes, certainly the last time I checked, our national facilities here in Australia, the Anglo-Australian telescope at Siding Spring, the 3.9 metre reflector, and the various radio telescopes, I think they're still operating with minimal staff. And and no visiting observers. But one thing that has changed, and this is outside our control, excuse me, Andrew, I've got a frog in my throat. Just clear. Probably
well, I hope that's all it is.
Yes, I do too. COVID-19 getting its own back. The European Southern Observatory telescopes at Cerro Paranal and La Silla, which we in Australia now have access to because of the 10-year strategic partnership, which was signed back in 2017. That is a very important pillar of Australian observational astronomy, certainly at optical wavelengths. But those facilities have actually suspended their science operations, and it's all about protecting staff. So there aren't going to be any, I think that's already come into practice. If not, it's going to happen very soon, that there won't be any more scientific operations taking place there. So people who've got time awarded on those telescopes, we don't know quite what the situation will be, whether they will lose that time permanently and have to reapply, or whether there'll be some sort of compensation. My guess is that they will have to reapply, because that's what happens if you get bad weather. You just lose your time, and you've got to start again. So that's perhaps one of the biggest effects of the coronavirus. We, our thoughts are, of course, always with people who are more directly affected. Tens of thousands of people stand to lose their jobs and have lost their jobs in Australia, as with many other countries. At least so far so good that astronomers are on fairly short-term contracts, so there might be long-term consequences of the virus, particularly with universities that rely for a lot of their income on overseas students, because that has dried up as well.
Yes,
so
we've seen that even in Dubbo, where we have a university campus and students are not going in. So it's getting down into the real depths of society and causing all sorts of mayhem. But no end in sight at this point in time, which is
we will get through it.
For sure, but
there's no doubt about that. But it's a very, it is comparable with, I kind of think of it as World War III, actually, because it's going to have that sort of effect on people.
Yes, indeed. All right. Let's answer a couple of questions from the audience. This question comes from Josh Vince. As I understand, in the theory of oscillating universe theory, it would state that our universe is existing between a bang and a crunch, which could be the first or the nth.
Or the nth, yeah.
Nth. I have read that the cosmic wave, background wave radiation data shows that we are in fact just expanding until a heat death. What would legitimise the oscillating theory? What creates this theorised crunch? Could it be from the supposed nature of dark energy, where it is both repulsive and attractive? Just like us, Fred. If so, how would it start to become attractive? How would it start to become attractive through the pull of the universe back into one dense spot? I'm clearly not a cosmologist, but this theory and the nature of dark energy really blows my mind. Apologies if this is a nonsensical inquiry. Thanks, Josh. It's a nonsensical inquiry, I venture to say.
Absolutely. It's a great question. And Josh, we apologise that it's taken us till now to get to your question, because you posed this back in July last year. So I hope you're still listening. But if not, this might be of interest to other people. Excuse me. Yes, it was, particularly during the 1970s, we were, in the world of astronomy, convinced that, or the expectation was that while we could measure the current expansion of the universe, if you could look further back in time in the universe, we expected that we'd find a universe that was expanding more rapidly, because the expectation was simply that the universe's expansion would slow down. We knew that it had been expanding for, 13 or 14 billion years. The best guess we have at the moment is 13.8 billion years. So that expansion is well charted. But what was a big question at that time in the 70s and 80s is, how is that varying over time? Is it slowing down as we would expect? Why would we expect it to slow down? Because the universe is full of stuff. and that stuff all has gravitational potential. So we would have expected the galaxies and all the rest of the stuff in the universe to act as a brake on the expansion and slow it down. And in fact, exactly as Josh mentions, one of the theories that was quite popular in the 70s was the idea that the expansion or the braking effect of gravity might actually be strong enough to overcome the expansion and eventually turn the expansion into a contraction and give us what was usually called the big crunch. One person didn't call it that. That was Brian Schmidt, now Vice Chancellor of the Australian National University, who always called it the GNAB Gib, which is Big Bang
backwards.
Yeah, GNAB Gib, which I always thought was
still makes me giggle. I love it.
Yeah, it's a great notion. More often called the Big Crunch, but it was actually Brian himself, of course, and other competitors, actually, although they all arrived at the same answer in the United States, who back in 1998 realized that actually the expansion is increasing. And that's, as Josh correctly mentions, that's due to something we now call dark energy, an energy of space itself, which means that the more space you have, the more energy it has, and the more rapid the expansion becomes. So it's the accelerating expansion of the universe. So unless something changes, unless that is a temporary phenomenon, and we don't really have any way of telling that, we're just basically taking the assumption that what we see now is what is going to continue happening, then yes, exactly as Josh says, the universe ends up with a heat death. This is a very old term, actually. It goes back to the 1950s, the idea of the heat death of the universe, that basically you just run out of star fuel, stars stop shining, and you've just got a lot of cold objects that basically have nothing, there's essentially they're not heating the universe up at all. The universe becomes a cold, dark and miserable place, terribly boring. Heat death sounds better than the boredom death of the universe, but that's basically what it is. So Josh's question really is, what would bring back the oscillating theory? It would take something pretty spectacular, but he might be on the right lines. If you could show that dark energy was a temporary phenomenon or one that might somehow reverse, then that might bring back the oscillating theory. At the moment, we have no idea what dark energy is. We assume that what we see is what we get, that dark energy, to the best of our knowledge, as space increases, dark energy increases. And that tends to rule out any thoughts of an oscillating universe. So it looks as though that theory has had its death knell with the accelerating expansion. But it's still an open question at some level because of our really lack of understanding of exactly what dark energy is. All we can do is look at the way it behaves, and the way it behaves seems to be that it gets bigger as space gets bigger.
Okay. Thank you, Josh. Great question. Let's move on. This one comes from Paddy. I'm a roof plumber by trade and drive around Sydney quoting jobs, and your podcast is my new radio. Isn't that nice? Thank you, Paddy. My question is, what type of digital imager should I purchase for my new telescope that I was inspired to buy from listening to your podcast? Wow. The telescope is a Skywatcher Dobsonian's 150mm/1200mm. Through the eyepiece I can see Jupiter and its 4 moons, but would like to be able to take some pictures to record the experience. Yeah, who wouldn't? Where can I take the telescope in New South Wales where there is no or minimal light pollution, I think he's getting at there. Look, at the moment, Paddy, nowhere. Have a wonderful day. May the force be with you, etc. Okay, yeah, good question. I mean, we've got the technology these days to take these spectacular photos of just about anything. My little pocket camera, which cost me next to nothing, has got 40 times optical zoom. So I during the bushfire crisis recently and then the dust storms, I took some incredibly spectacular sunset and sunrise photos through the haze, and big pink, billiard ball sunrises, and I did it all with a pocket camera. So I suspect that he might only need one of those.
So you're telling him he doesn't need his Skywatcher Dobsonian, which
he probably needs that to get the close-up image that he can then photograph.
Yeah. It's a nice telescope that Paddy's got. Paddy McManus, his name is, and sadly, once again, I hope Paddy's still listening, because this came in about 3 months ago, I think, or 4 months ago. So thank you very much for your question, Paddy. It's a great question. Let me just highlight something for your benefit, Andrew.
Yep.
Because he says, where can he take the telescope where there is no or minimal Allen? And Allen, you correctly interpreted it as light pollution, but Allen is a real acronym. It means artificial light at night. And so
I knew it was something like that, but I just couldn't get my head around it.
Yeah, that's right. No, it's just, it's a good thing to bear in mind, because occasionally we see references to Allen and you think, who's he? I don't know Allen, but it's artificial light at night. I mean, Paddy might have already gone and bought a camera, and if he has, I hope it's doing well. A Dobsonian is, so this is a telescope that was invented by John Dobson. It's actually what's called a Newtonian telescope. It uses Newton's idea of a mirror, a big dish mirror at the bottom, and a tilted flat mirror to bring the light out to an eyepiece at the side. It's a very common type of telescope. The Dobsonian bit is that John Dobson, who sadly is no longer with us, he basically invented the idea of a really crude telescope just made out of almost a wooden box for the mounting, that you can actually basically just point the telescope in any direction in a very straightforward and simple way, without any knobs and bells and whistles and things of that sort.
Yeah.
And it works well. It's good for looking at the planets, for looking at stars. What it doesn't do is track on the sky. You can actually buy attachments that will let you do that, but then you're in a slightly different regime. So you're not going to be able to use it for taking long images of nebulae and things like that, which needs a more complex mechanism for tracking on the sky. But this is a 6-inch telescope, a 150 millimeter. It's a decent sized telescope. I would have given my eye teeth for one of those when I was a youngster getting interested in astronomy. So it's well worth having, and you'll get, as Paddy says, you'll get great views of the planets, Jupiter and its moons, Saturn's rings, and for that you can almost use your iPhone pointed at the eyepiece, your smartphone, or your pocket camera, because you only need a short exposure. You can do an exposure in, I don't know, 20th of a second or something like that. You're getting enough light from the sky that you will record the image.
And if you're doing it at night, Paddy, the flash is a really good idea.
Yes. Quite so. That's what you need for taking pictures of the people who are standing watching you, except there won't be any because they're all at home because of COVID-19. Right. So you might have to do your selfie with the flash.
Yeah.
For more complicated things, you're talking about a change of telescope mounting. It's got to be something different from that. A Dobsonian won't let you do deep sky photography without the additional gizmos. And then you probably want to buy a rather higher level digital camera. But I hope that's helpful. Actually, a standard single lens digital reflex camera can be adapted to a telescope. Often you can get an adapter. You take the lens out and basically, take the normal photographic lens off, take the eyepiece lens out and let the telescope itself be your lens.
Yeah.
That, again, is slightly fancier, but it's a good way to do it.
Yeah, I'd probably get a different camera so you don't ruin your good one. Or,
Well, there's that possibility too, yes. If you're going to take a shovel to it, as they did with the InSight lander, then yes, buy a second-hand one.
Yes, indeed. All right. Hope that helped, Paddy. Thanks for the question. Good discussion too. Probably give some other people some ideas as well. Fred, that's just about it. Thank you again, as always. Stay safe.
Doing my best, Andrew. The same to you too. Make sure you keep your, keep your distance from all the people around you.
Yeah. Oh, look, they've defined radio as a necessary service. So
Yeah.
Damn.
It's all right. You do it for pleasure anyway.
Yeah,
so.
I do.
Yeah.
But anyway. And don't forget, the Space Nuts shop, bytes.com/space nuts. That's BITESZ. There's all sorts of things there. Fred's new book, my new book, I think, which is available for pre-order, the Turanian Enigma and Cosmic Chronicles. And Hugh assures me that he's now got the logos sorted out for the new polo shirts, and I think there are caps. And so pop along and have a look. Woohoo! Because I've got such a great computer, none of the graphics work, so I can't see them. Damn. I'll try a different computer one day. But yeah, bytes.com/space nuts. You'll find the Space Nuts shop there, as well as all our episodes, as well as the little interface where you can send us questions. You can do that through the website as well. And thank you for joining us. Thanks for your input. Thanks for, continually supporting Space Nuts. It is so greatly appreciated. And thank you, Fred. We'll talk to you again next week.
I look forward to it very much, Andrew, and stay safe and stay well.
Indeed. Professor Fred Watson, Astronomer-at-Large, and from me, Andrew Dunkley, thanks again. We'll see you next time.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at bytes.com.
This has been another quality podcast production from bytes.com.